Okay guys, this is class 11 and part 11 I'm gonna upload on YouTube. Today I'm gonna talk about coding with the if and for in Matlab, and this is a very important part of the course because when you go to upper level courses and you see with the research, and you have to learn how to code in Matlab. Okay, so we were here. Okay. So let me do this like that, and then we can move forward. Okay. So if command. A general form of if command is as follows. So if set condition 1 is satisfied, we're going to ask that the MATLAB does this kind of operation, calculation 1. Else if condition 2 satisfies, calculation 2. Else if and the end. But in reality, we don't have the else if condition in MATLAB for many times. In short, if I want to summarize, we have the if condition 1, calculation 1, else if condition 2, calculate 2, and the end. This is for logical that I want present here. This is how we think this, right? So although the simplest version of if command is if condition 1 satisfied, do the operation 1, else there's no condition here. In else if we have condition, but else means if this not satisfied, do the calculation this and the end. Understand? So now let us try the following command. So we are going to the M file in MATLAB. Okay, so I'm going to save it as command and if. Okay, command and if. Then always you have to put CLC, means to clear the workspaces, right? Always you do that. So now this is the metrics that we want to see. A is equal to 1, 2, minus 3, minus 4, 5, 9, sorry, 1, 4, 7. Here we go. See, if I run this, guys, come on. If I run this, it's recording, yeah. If I run this, guys, I'm gonna get this matrix 3 by 3. That's right. So, and now I'm writing if diagonal elements of the matrix A, that I taught you in the YouTube links that you have it, greater than or equal to 0. This is how we write it. Greater than or equal to 0. See, right arrow, equal to 0. That's right. If this condition satisfied, new diagonal, I'm saying, for example, is diagonal elements of A, matrix A, plus 2, and end. For every if, you have to have an end. So now if I run this, this is what we get, guys. Here we go. See? Let me change the places here, guys. Yeah, like this. So this is matrix A that shows, and because the diagonal elements of A are 1, 5, 7, they are greater than 0. That's right. So I'm gonna say assign a new parameter, new diagonal, and diagonal elements of the A plus 2. So 1 plus 2 is 3, 5 plus 2 is 7, 7 plus 2 is 9. We got it? But now I'm gonna put else command. Else, right? Else means that if the diagonal elements of A is smaller than 0, automatically. So it says if that the case, get here, guys. If that the case is else. New diagonal is equal to diagonal of A. End. Understand? Huh? So let us run this. But again, gives me 379 because the first condition is already satisfied. So it's gonna carry out this, guys, this calculation, not this. That's right. Now continue with the coding. Okay, so now the rest is if A, matrix A, all rows and second column. What's the all rows and second column? So this is second column, this 2, 5, 4. All rows means 2, 5, 4. Second column, this is greater than or equal to 0. Okay, is greater than or equal to 0. So what it says, new dark underline 1, I say here because I don't want to confuse with the previous command, is equal to diagonal elements of A multiplied by 2. Else, if the second rows and 2 is not greater, means it's smaller than 0, else new diagonal underline 1 is diag of A divided by 2 and end. Let us see what we get. Here we go. So new diag, because second rows and all columns gonna be what? 2, 5, and 4. They are positive. So new diag we diagonal elements multiplied by 2. 2 by 1 is 2. 2 by 5 is a diagonal element is 10. 2 by 7 is 14. If you want to double check, you can have this. You can have diag of A to show you. Look at here, guys. Here we go. Diag is 157. 2 times of that gonna be 2, 10, 14. That's right. Understand. So let's go another kind of coding. If, okay, if, here we go. This is if A 2 and 1 is smaller or equal to 0, so new diag underline 3 to not confuse with the previous commands is diag of a matrix A multiplied by 5. Else, if the second row and the first element is smaller than 0, new diag and underline 3 is equal to diag element of A minus 2 and end. Okay, so 2 and 1. So guys, see, let me show you. 2 and 1. So second row, first element. This is minus 4. It says if minus 4 is negative, so this condition satisfies, multiply the diagonal elements of A by 5. If it's positive, do this. So first, let us run this. So you say the diagonal 3, it can run this because the first condition satisfies, minus 4 is less than 0. So diagonal elements by 5. Again, I'm putting diagonal here to compare. Diag A, that's right. Oops. Look at here, guys. Diag A is 157 multiplied by 5 is 5, 25, 35. So now I'm going to change it. I'm going to say, you know what, is greater than 0. Okay. So I'm saying if second row and the first element of the matrix A is greater than 0, second row and the first element is minus 4 is not greater than 0. So we're going to skip this because this is not valid. Gonna go to else, that's right. So this gonna make it minus 2. See here, diag A, oops, diag A. Look at here, guys. This is what we get. Oh, so this time the code does this. That's right. Diag is 157, as I taught in the previous class on a YouTube link. And now it's gonna be diag minus 2. 1 minus 2, minus 1. 2 minus 2, 3. 7 minus 2, 5. See? This is the logic of your brain that we are translating in the Matlab. Understand what I'm saying? Now, first of all, let me teach you. I want to make these comments. I'm selecting all of them. If you right click on this, guys, right click on that. So you see that there's a comment command, that's right, Control L. So get here, I'm again selecting again like this, Okay, selecting all of them. So if you push Control and then R, it makes comments. So after this, these commands are commands until that you need them. If you need them, again you select all the codes that you have, Control L and T. Now uncomment. See, this is not uncomment. Now these are commands again. So again, I'm making comments. That's right. Control and this. Why? Because I'm going to teach you another type of if commands. If A1, okay, is 1, 2, 2, 4, 5, 1, 0, 1, 0, 0, 3, 4, minus 5, 6, 0, 0, 0, 0, 0, 0, and 1, 1, 1, 1, oh, 1, 1, 1, 1, 1, and 0. Here we go. This is 5 by 5 guys matrix. If I run it, it's gonna skip the old commented commands and first clear the workspace, then type the 5 by 5 matrix A. That's right. Now this is my command. I say if, okay, if A1, okay, if A1 and fourth row, oh no, if determinant of, guys, determinant of, I told you this, right? Why I'm doing like this? Determinant of matrix A1 is greater than equal to 0. Okay, I'm going to show the determinant of A. I'm going to type for minutes, right? If that's the case, A2, okay, A2 gonna be what? A2 gonna be a third row and all columns power of 3. See? And I'm saying it determinant of this matrix is greater than or equal to 0. First type that determinant for me and then assign these to the new parameter A2. Third row, this is a third row, guys. Okay, and all the columns. So third row is 3, 5, minus 5, 6, 0. So this is a vector, that's right. So when you're dealing with it, as I taught to you, if you put to the power or divide, you have to put dot score or dot divided, right? Remember that the YouTube link you have it. Let me see it. Let me run it. So when I run this code, this if, okay, this if, it shows determinant is 136 satisfied greater than 0, then it's gonna show me A2 is 183 to the power of 2. See here, guys. Oh, what did I say? Oh, there's a typo here, guys. A1. Okay, I see that. It's 136, so A2 is so A third row, look at here, guys, and all the columns. 3 to the power of 3 is 27. Look at here, 27. You got it? 4 to the power of 3 is 64. Minus 5 to the power of 3 is minus 125. 6 to the power of 3 is 2160. That's right. 216. So 0 and 0. So it gives you that. Now, I'm going to make it a little complicated. Now I say else if. Okay. Now I say else if. Now I want to do the else if. Else if, now I say, okay. Hold on, guys. It's freezing. Guys, it was a typo here, guys. I see that. This is A1. Okay. See here. Oh. Let me first fix this because there's a typo that I had here. Here, guys, right here. I'm gonna do the same because I was wondering, because the rows here are 0. Remember I taught in the previous classes, if one row of a matrix is 0, its determinant is 0. Why? Because I taught you that the rows of this matrix are linearly dependent, so the matrix is going to be 0 and is not full rank. That's right. So you have to avoid this kind of typos that I'm making here. This is good actually lesson for you. So, but at the end of the day, the answer is the same as before. Now I'm gonna change it to a little challenging. Else if I'm saying else if what? Recording? Yes. Else if I say if A of A2 and 3, 2 and 3 is the second row and third column, is greater than 0, and this sign is and in Matlab, guys. Okay, and okay, and A 5 and 5, okay, is greater than or equal to 0. Okay, so when I say and this condition, guys, and this condition, both must be satisfied. Both must be. Okay, okay. Else if this, now I'm saying A3, oh, I'm gonna say A3 is matrix A1, okay, matrix A1. Then, as I taught you, fourth row and for all the rows of the fourth column to the power of 4. Let me see what it gives. Okay, understand? Now let us see, guys. Here we go. Okay, first of all, because this is valid, it's gonna skip this. Understand what I'm talking about? Because the MATLAB is not stupid. Because you say this if is valid, so it kind of does it and goes to the end after end. It breaks the comment here, right? So you cannot expect that you have two valid condition and gonna run the both. So I'm gonna make it one of them invalid. How? I'm gonna say it is smaller than 0. But here, guys, if the determinant of it is smaller than 0, do this. But we know that the determinant of the matrix is 0, so it's gonna cancel this out, this operation. Look at here. This is what we got. Oh, this is again A1. I don't know why I say type A always. Okay, here we go. This is what we got. Understand? So, because the determinant is 0, so this operation is being cancelled. Skip to the else if. They both are correct because A2 and 3 is 1 is greater than 0 and A1 5 is 0. Both cancel, so it kind of does that for me. Understand? Or you can do this. This is 1 and say A4 also is or you can do this. Say A1, okay, A1 A1 and 4, okay, plus 10. This is what we get, guys. Here we got. Okay, so A1 and 4 means this 0 0 0 0 0. Sorry. So A1 and this command is to the power of 4. That's right. Let me show you. See, this is matrix. All rows and 4 columns is 5 0 6 0 1. In the previous case, we're saying to the power of 4. So what we're gonna get is 256 1296, and there is 0 0 1. In the second one, it's gonna be I said calculate, and I'm naming as A4. A4. See here? That. And this was what 10, 10, 14, 10, 16, 10, 11. And so on and go. Okay. So now, what if I say another else if? Obviously, if I have enough else if, Matlab is a distributed. Only calculate this for me, not the other else if. Understand what I'm talking about? Okay. So this is how we do coding in Matlab. There is. Okay. So, and that's it. Okay, guys. And another point in if, no, we don't have it. Okay. So now let's go to the for loop. So please do it at home, please, with me. You get what I mean, okay? For loop. Before discussing loop command, let us introduce a trivial command in Matlab. A parameter capital A is A with time with the interval of B to C. We get a numerical series as follows: A plus P, A plus 2B, A plus 3B until the C. If we remove B from here, we get like this command, A to C. So Matlab automatically adds 1 unit to the A plus 1, A plus 2, A plus 3 until the C. So now let us try these series together. Okay. So I'm gonna first save it as comment 4. Okay. So then again, CLC means clear the workspace. Okay. Also, we have another command in Matlab, guys, that you have to, when you are a professional code developer, it is clear all. This command clears all the parameters that save in the workspace. This is very good command and very useful command, guys. I recommend that as a professional code developer, when you're trying to develop a code, use both of them. After each run of these, after each cycle after running the code, it's gonna help you to avoid difficulty in getting the results. So now, so A is equal to 0 to 10. If I run this, guys, see, 0, 1, 2, 3, 4, 5, 6 until to 10. Because we allowed Matlab to automatically add 1 unit to the 0, 2, 3, 4, 5, 6. But if I say A is equal to 0, 2 to 10, now we define interval. Interval is 2. So it's going to be 2, 4, 6, 7, 8, 2, 4, 6, 8, 10. Okay, here we go. 0, 2, 4, 6, 8, 10. And the A is, here we're saying, is 10 to 50. Now the intervals are, or steps are, see, 10, 60, 110, 160, 210, 263, until to 960. But what, you're gonna say, hey, you told us 1000, but this is the upper limit, you cannot exceed that. So 960 plus 50 gonna be 1010. That's gonna be invalid. Or A is equal to 1000 in now incrementally 0.5 to 1010. So you're gonna have a bigger vectors, right? Or you can reverse it. Like you can say from 20 to -1 to -10. Okay, see, 20, 19, 18, 17, 16, 15, because the interval is -1 until reaches to -10. This is how we generate intervals for the coding in the Matlab, and it's very important, guys, super important. You have to know how to do it. Okay, especially when you're dealing with the for, or when you're dealing with the ODE solvers in the MATLAB for solving differential equations that I'm going to teach you eventually. Okay, recording, yes, understand? Now we can introduce command loop. As its name implies, loop command carries out one or many calculations subject to a certain series. Okay, so this is the general structure of the for. First of all, for a certain series that you generated like this, okay, oh, what happened? Okay, like this, in if, okay, in if this gonna repeats this operation, calculation 1, calculation 2, calculation, until it, for each value of these series that you generated. Okay, how to do that I'm going to teach you the next class.